Okay. Hello, everyone. I am Jianguang Zhang. Welcome to my presentation. Quantitative analysis of Triassic-Jurassic pollen and spores for paleoenvironmental and paleoclimate reconstruction based on the spore pollen database. Last year, I got my doctoral degree at the Technical University of Darmstadt, Germany. This study is the main part of my PhD thesis. During this study, I created a new online database to collect and organize spores and pollen data. This presentation is to give you a basic idea about how I create this database and how I use the database for paleoenvironmental and paleoclimate reconstructions. This presentation is composed of 6 parts. In the first part, I will talk about the reason to create this online database. In the second part, I will talk about how I collect data to create the database and what can we do by using the database. The third part is a published paper. I will talk about how I link the discussed Mesozoic sporomorph genera of bryophytes, pteridophytes, and gymnosperms to their closest parent plants and the eco-plant model. Based on the result in the third part, the first part, also a published paper, will talk about how to create a new interface to quickly link the discussed sporomorphs to past vegetation patterns and climatic changes. The fifth part is a case study to demonstrate that the database I created is a reliable tool for paleoenvironmental and paleoclimate reconstruction. In the last part, I will give a summary for this study. My motivation of this study will be introduced by answering the following question. What are spores and pollen? Which characteristics do spores and pollen have? What can spores and pollen be used for? Which methods do we use to study spores and pollen? What are the problems to use spores and pollen? To introduce what are spores and pollen, I would like you first to have a basic idea of plant. Based on the vascular system, plants are divided into non-vascular plants and vascular plants. The non-vascular plants are divided into algae without stalk and bryophytes with stalk. The vascular plants are divided into pteridophytes without seed, gymnosperms with seed but without flower, and angiosperms with both seed and flower. Seedless plants produce spores. Seed plants produce pollen. Spores and pollen are also called sporomorph or sporopollen. Plants use spores or pollen to produce the next generation. You can simply take spores and pollen as the egg and the sperm of plants. Spores and pollen have 4 important characteristics. That is why they are widely used. Firstly, they are small. Normally, they are only 20 to 100 micrometers in diameter. Secondly, they are abundant. A flower can produce about 200 million pollen grains. A tree can produce about 20 billion pollen grains. And there are at least 10,000 sporomorphs in a gram of silt stove. Thirdly, they are stable. Their wall is chemically inert so that we can easily extract them from rocks by using hydrofluoric acid. Here is a video to let you know how small and abundant they are. Finally, they are various. Different plants produce different spores or pollen.
Something wrong? We do not hear you.
Okay.
Mm.
Next.
Жень, что-то не так ведь, да?
Yes.
Мгм.
Упал звук.
Смотри, у него просто выключен звук.
Да. One moment.
Now
Oh, now.
it's okay, right?
Share your screen again.
And you need to share your screen once again.
Okay.
Мгм.
One. Okay.
Yeah. Yeah, you may continue.
From which page?
The last one was with video, and the one after it. Oh, this one. Yeah, we saw it. We saw video, and after video, problem started.
Okay.
Now. Oh la la. Again, something wrong.
We skip this slide.
The plants produce.
We do not hear you, and we see your portrait, not a video of your face. Ay, ay, ay. We do not hear you.
Now
here. The same problem appeared because you stop moving and we stop listening to you, and now no, your screen is visible.
Maybe go to next slide.
Perhaps something wrong with the slide, with particular slides, this one.
Okay, now you can see my screen, right?
So far, everything okay.
Okay, let's continue. The last characteristics of pollen is that they are various. Different plants produce different spores or pollen, but for the same plants.
Something wrong again. We do not now hear you, but the same problem.
Is that from me or from the app? I don't know.
Now we can see you, can hear you, but we do not see your screen. Okay, we
Okay.
see
No.
screen.
Maybe next slide.
Switch to the next slide. Perhaps something wrong with this particular slide.
Okay. So what can we use spores and pollen? One of the important usage for spores and pollen is stratigraphic analysis. Different geological times have different plants which produce different spores and pollen. Besides, spores and pollen fossils are abundant and easy to be extracted from rocks, so that they are often used in the stratigraphic analysis. Another important usage for spores and pollen is the paleoclimate analysis. Different climatic conditions have different plants, which produce different spores and pollen, so that spores and pollen are often used in the climatic analysis. Visible light microscope, scanning electron microscope, and transmission electron microscope are the three main methods to study spore and pollen morphology. But the latter two methods can reveal morphological features that are not observable by light microscope. However, light microscope is still the workhorse method to study spore and pollen morphology, and it will remain the case in the immediate future. For the Mesozoic, most of the dispersed sporomorphs have been described under light microscope. Currently, it is still difficult to use the Mesozoic dispersed spores and pollen for climatic and environmental reconstruction. To use spores and pollen, they must first be identified correctly, but more and more general are reported. It is difficult to organize and identify them. For most of the Mesozoic dispersed spores and pollen, their parent plants and climatic implications are either uncertain or debated. Systematic reviews are needed. For the quantitative analysis of spores and pollen, plenty of calculations are required. It is time-consuming. To solve those problems, a robust database system is created to help organize and identify spores and pollen data. The database will be introduced by answering the following question. Where are the data collected from? Which kind of data are collected? How to organize the data? What can we do by using the database? Most of the data are collected from published books and papers so that they are reliable. And for those collected data, most of them are in English, Chinese, and German. Different kinds of data are collected. For example, about 270,000 extant and fossil plant pictures are collected. About 114,000 spores and pollen pictures are collected. They are under visible light microscope, scanning electron microscope, or transmission electron microscope. About 32,000 spore and pollen descriptions are collected. Most of them are for the holotype. Besides, more than 2 million occurrences from about 70,000 references are collected. All of the collected data are stored in different tables, which are related to each other. For each collected item, its reference is well recorded, so that the reference of each collected item can be traced. The database system is created by using MySQL as the database server and PHP to create the dynamic website. Complicated analysis methods are summarized as the flowchart, which can be followed steps by step by computer. This is a flowchart to draw the age distribution plot for stratigraphic analysis. The occurrence data need to be calculated for the occurrence percentage of each geological time unit. Then the flowchart is compiled into PHP code. Finally, an interface is created based on the PHP code, so that the user only needs to input a genus or species name into the database, then click the plot button. The result will show up in a few seconds. The database is published online with the address of sporopollen.com. Different interfaces are created by clicking the menus. Users can query data either in the form of datasets or on a map. It also can help users to identify their pollen samples. Besides, it can also be used for quantitative, stratigraphic, or paleoenvironmental analysis. It provides many open access. For the full use of the database, the users must register an account with my permission. One of the important usage for this database is for spores and pollen identification. You select one or more characters, search the data, the result will show up in a few seconds.
No results so far?
No result.
Mm-hmm. Ah.
So
no results.
Yeah, pictures.
Uh-huh.
Picture. So click the select the characters and click the search button. There will be result of swallow more. Another important usage of this database is to link the dispersed spores and pollen to their parent plants. Input a genus name of the spores and pollen. Click the search button. You will get the information about its parent plants. All the collected literature will show up together with the pictures and the description of the genus. Click the genus. Click the picture, we'll get all the pictures of this genus. And click the genus name, we'll get all the descriptions of this genus. For most of the Mesozoic dispersed spores and pollen, their affinities are either uncertain or debated. We have to systematically review them to get rid of the debate and link them to their closest parent plants. But to do this is not an easy way. This will be discussed in part 2. With the help of the collected data in this database, dispersed Mesozoic sporomorph genera of bryophytes, pteridophytes, and gymnosperm are reviewed by comparing the unique outline and the sculpture of the sporomorph wall with that of modern plants and the in situ fossil plants. Before I start this part, I would like to first introduce the concept of the ecoplant model. The eco-group classification based on the growth form of plants was established by the pioneering work of Warming in 1895. They analyzed diverse plant associations with relation to principal climatic elements, such as water, heat, light, and air. The ecoplant model has been widely used for extant Cenozoic, Mesozoic, and Paleozoic environmental reconstructions. According to hydrologic and temperature conditions, the ecoplant model classifies plants into different the effect of humidity and the effect of temperature groups due to their climatic preferences. The sporomorph eco-group model, also called the SEG model by Abinker, is also commonly used for Mesozoic paleo-environmental reconstructions of Europe and some part of China. It represents a simplified ecoplant model. In the SEG model, due to uncertain botanical affinity of some sporomorphs, several plants indicating a different climatic and environmental information. Therefore, for this study, the ecoplant model has been chosen since it allows for more details and precise statement on paleoclimate than the SEG model. Here is link the dispersed spores and pollen to their parent plants and the climatic patterns. The first step is to link dispersed spores and pollen to their parent plants by comparing sculpture and the structure to the extent or in situ spores and pollen. Then, based on the living conditions of their parent plants, link spores and pollen to different climatic patterns. Here is an example to link the dispersed spores to their parent plant and the climatic pattern. Firstly, we know a plant family. We collect the extent and in situ spores of this family. They are chilled, straight, with or without auriculae. There are 10 dispersed macrospore genera related to this type of spore, so that we believe those 10 spores are related to this family. By reading the literature, we know the species of this family are widely distributed in tropical and subtropical regions, so they are megathermic plants. The genera are generally mysic and mesophytes, so we know all of the spores related to this family are from megathermic plants and mesophytes. These are all the genera related to this family. Those genera marked with the flashes are from extant or in situ plants. Those without flashes are dispersed spores. This is an easy example. Actually, it is difficult to separate the spores and pollen from one group to the other. High-resolution studies under scanning electron microscope and the transmission electron microscope are often needed. To explain this, I would like to introduce a little bit more about how we study spores and pollen. Light microscope, scanning electron microscope, and the transmission electron microscope are three main methods to study spores and pollen morphology. The last two methods can reveal promised features not observable by light microscope because of their higher resolution. Here are pictures to show you the difference between light microscope and scanning electron microscope. We can know that for the same thing, scanning electron microscope can reveal more detail. Before my study, palynologists can only use the SEG model provided by Abink to reconstruct the Mesozoic climate. However, the model was only for the study under light microscope with lower resolution. The problem of light microscope method is that it cannot guarantee that the parent plant can be traced. Here is an example. Ginkgolis and Psychedelis are quite different plant orders. Under light microscope, their pollen grains looks the same. Under scanning electron microscope, you can see some differences. Under transmission electron microscope, their differences are remarkable. So in most cases, high-resolution studies under scanning electron microscope and transmission electron microscope are needed. Here are all the published bryophytes, pteridophytes, and gymnosperms for all of those plants and climatic patterns. I linked the dispersed spores and pollen to them. Some plants have extant descendants. It is easy to link the dispersed spores and pollen to them because we can get as much spores and pollen as we want. Some plants are extinct. Only in situ spores and pollen can be used. It is difficult to link the dispersed spores and pollen to them because of the limited fossils. For all the reviewed Mesozoic dispersed sporomorphs of bryophytes, pteridophytes, and gymnosperms, more than half of them can be linked to their parent plant at a family or level. Less than half of them cannot, mainly because of the lacking of high-resolution description. For the quantitative study of spores and pollen, many calculations are required. Besides, the researchers must know the parent plants and the climatic patterns very well. It makes the quantitative study of spores and pollen difficult. A database-based interface is created to solve this problem. These climatic patterns and parent plant information are stored in the online database. When spores and pollen abundances are uploaded to the database, they will be automatically linked to their climatic patterns and parent plants. Abundances are also automatically calculated. Different options are provided. The result can either be a dataset or a diagram. If you select to create a PDF file, the result will be a diagram. If you do not, the result will be a dataset. Here is a case study from Northwest China to show you how this database helps users to analyze spores and pollen data quantitatively. In Xinjiang, Northwest China, an almost continuous continental sedimentary record throughout the entire Mesozoic has been documented. In particular, at the Upper Triassic Jianguang Formation, the Triassic-Jurassic transition is well developed. It yields a diverse assemblage of fossil spores and pollen. In total, 37 samples are taken from the 10-meter lignite seam of the Jianguang Formation. Among the 37 samples, 30 of them preserve abundant sporomorphs. Scanning electron microscope pictures have been taken for identification. Light microscope pictures for the abundance calculation. The spores and pollen abundances are uploaded into my database for parent plant and climatic reconstruction. The parent plants are reconstructed at the order or family level. This is the first time the parent plants are reconstructed at this level. Based on the cluster analysis, both the parent plants and the climatic patterns can be categorized into 5 groups. Despite the different groups, the parent plants are dominated by Corystospermalis, Bonatialis, Ginkgoalis, and Glacianialis. The plants are mainly hygrophytes, mesophytes, and megathermic plants. We can note generally the climate is medium. Occasionally, there was some dry season and wet season. The region was in a tropical or subtropical region. Based on the results, the paleoenvironments of the late Triassic are reconstructed. The area of water indicates the relative humidity, and the size of sun indicates the relative temperature. We can see for different groups of the late Triassic, the plants were generally the same. There were some differences in humidity and temperature, but the plant differences were not remarkable. Based on the published sporomorph abundance, the paleoenvironment of early Jurassic is also reconstructed. The result shows the flora was dominated by tree ferns of Caesalis in the early Jurassic. It is quite different compared to the later Triassic. The climate was wet and hot. My study is the first time in this region to quantitatively reconstruct the paleoenvironment and paleoclimate in such detail. The former study only gave abundances of spores and pollen. No parent plants and climatic patterns were reconstructed. So for summary, spores and pollen are the fingerprints of the plant. Our online database is created to collect the spores and pollen to help the user to identification paleoenvironmental and paleoclimate reconstruction. With the help of the database, the Mesozoic dispersed spores and pollen are linked to their parent plant and climatic pattern. Interfaces are created to help users get the parent plants and climatic patterns result in several seconds. A case study shows the database and our linked parent plant and climatic patterns are useful to reveal past vegetation patterns and climate changes applicable to other Mesozoic assemblages. I would like to thank all the people who helped me during this study, especially Dr. Jens Horner and Dr. Olaf Lenz. Thank you for your attention.
Thank you for the interesting talk. It was very exciting. Well, dear colleagues, you are welcome to switch on your phones and ask questions. Raise your hands and ask questions if you like, or write your questions in the chat, and then I will read, and Jianguang will read the question and answer. Comments are also welcome. Well, meantime, may I ask the first question? Well, your database, does it devote it to Mesozoic pollen and spores, or it embraces also some of Paleozoic or Cenozoic?
Yes, this is my database, and here I can So here is all the collected sporomorphs, or we can say spores and pollen. You can see we collected about 6,000 genera. It is from Paleozoic to extant from today. So this is all kinds of pollen and spore.
Thank you. And I see a question in the chat. Please look in it. Thank you for a very interesting talk about a floral transition from Triassic to Jurassic in China, which is different for the American continents on the opposite side of the Earth. I suppose BC is Bruce Cornet, correctly? So it's just thanks for your interesting talk.
Okay.
Well, and I'd like to add a comment that I have used this database and I really like it, perhaps not for the goals that the author mentioned it, but it's really useful as a help to find references for all for a particular taxon that you need to learn about. I usually use it like this, and I always thankful to the author.
You're welcome. But I think the most important usage is for sporomorph identification. For sporomorph study, the first problem is from the identification.
Yeah, it's true. Well, I do not see if anybody wants to pose a question. I suspected there should be many. Well, what are you? Oh, I see something from Evgeny Karasov. Is there any application programming interface in the database?
Application? Yes. For example, for stratigraphic usage. So for the age distribution plot, you see, for all the genera or species collected in this database, if you put a name inside, it will quickly give you age distribution plot. And also for the group analyze, if you have more than one species, for example, this data, there are around 400 data in a data set. We can upload this data and quickly get the age distribution plot. No, there's some problem maybe. Okay.
Any problem with the connection? I suspect again. Jianguang? Oh la la. We do not hear you. Switch on your phone.
Okay.
Yeah, now everything back again.
Oh, okay. Yes. So,
well, and you see one more comment from Bruce in the chat. In North America, there is a mass extinction at the Triassic-Jurassic boundary called ETE, or End Triassic Extinction, where the majority of sporomorph taxa disappear overnight. Do you see any similar reduction in taxa diversity in China? The wet climate ferns are greatly reduced in North America, while the conifers become dominated by caryophytes and araucarians. So the question, do you see similar reduction in taxa diversity in China?
in China, it's opposite. You see, the Triassic is more dry, and the Jurassic is more wet. This is in my data case study. This result is in my case study. But maybe you can upload your data to my database to get the result. I think it can help you to quickly get the result. We can compare the data.
But what about mass extinction in China at this level?
Yeah. We have massive extinction in China, but you see this four group is late Triassic, but under the sixth picture is early Jurassic. Most of the plants in late Triassic disappear in early Jurassic. But the difference is that in China, the late Triassic is more dry.
Thank you. And in fact, I have one more question. What are your next plans for your database? How you're going to develop and to use it?
Yeah, the most of my time is for the usage of this database. In future, I would like to input some machine learning function inside this database. For example, to identify the spores and pollen. By machine learning, the database can help us to identify the picture automatically. Yeah, but I think that I need 1 or 2 years to finish this function.
Interesting. And also there is a new comment in the chat. It is also interesting if there is a similar reduction of diversity in the end Triassic of Siberia. But I don't know if its question is for you or not for you. Could you comment or you don't know?
I don't know Siberia.
Yeah, probably.
But maybe we can do something together. For example, if you have some sample, maybe we can do some forum of study together.
I don't think that we have the relevant material.
You do not have? Okay. Yeah.
Well, and one more comment from Bruce. I postulate in publication that the camp under formation of Atlantic Ocean was stimulated with much volcanism and CO2 gas due to CME or micronova that hit the Earth and irradiated with iridium and radioactive isotopes forming. Fossil fish are actually highly radioactive at the Triassic-Jurassic boundary, and dinosaurs' footprints become 3 times larger overnight, possibly due to the solar radiation. Well, could you comment on this, if you like?
Is this from China or which region? No.
This is from Bruce, his comment.
From which region?
In the chat. Do you see it?
The publication is in ResearchGate on Hatangian fishes at the in early Jurassic in my list of publications on ResearchGate. Go to Appendix A, and I give all of the data there. There's also another publication that appeared privately that I can send a link to that gets into contributions by Dr. John Brandenburg, who is a nuclear physicist, and Dr. Paul Laviolette, who is also an astronomer, who came to similar ideas that the Earth is occasionally hit with solar radiation, and that this is another form of influence that causes mass extinctions on Earth. But the distinction between a bolide or asteroid hitting the Earth, such as the form the Chicxulub crater in the Yucatan Peninsula that ended the age of the dinosaurs, and the one that hit Earth on just the Atlantic side, the rifting side of Pangaea at the end of the Triassic, are two very different forms of radical change in plant and animal taxa on Earth.
Yeah, I think the environmental change is bigger. It is clear in China, and comparing to your region, yeah, I think also the environmental change is bigger. Maybe there is some relationship, but I don't know where. Yeah.
Thank you, Bruce. Do we have other questions to the topic of the presentation? There is a comment from Evgeny related to the database. In my opinion, 2 captchas at the entrance to your database looks unnecessary. Too much. Do you agree?
Okay, thank you.
You will think about it.
I don't know what is the captchas. Captchas. What is captchas?
Captchas to, if I understand correctly, it is for computer to recognize if a person enters or some inhuman being enters to your database. This is for captures. Look, there's a picture in the chat. What does capture look like?
Okay. This is for security, because if you do not put this function, the machine will try many passwords, and my database will be down frequently. So if you are human, then you can input this security code. If you are machine, you cannot input correctly. Yeah. So I think it is important.
Yes, thank you for the interesting talk. And also the comment from Bruce that Chinese palynology and paleobotany is important to supporting these ideas he was discussing in the previous comments. And do we have, or we don't, more questions to the speaker? If we do not, so many thanks for the interesting talk and for your really useful database.
Okay.
Thank you.
Thank you very much for an interesting.
Thank you. Thank you very much.
Yeah, thank you. Very interesting.